Hello friends, welcome to our YouTube channel. Last session we discussed about the embedded device architecture layers. This section we can talk about the required security controls for each layer of the embedded device. Suppose if we are not consider these security controls, what security impact will give for the devices. So that aspect we can discuss today. Let's go to our topic now. So already we saw the embedded, generally we have the hardware layer, bootloader layer, kernel layer, operating system, drivers and libraries, embedded application. On top of that, hardware interfaces and communication protocols and communication workflows like firmware upgradation, data communication. So majorly these layers are there. Each layers we need to consider the security controls. That aspect we can discuss in this section. Okay, this is the sample device specification. Assume that this device have the interfaces like USB, CAN-FD, serial port, Bluetooth and Wi-Fi. The application layer services have in this device like SSH service, MQTT to communicate with the IoT core or IoT server, HTTPS, a embedded web server, and the data flows. This device have firmware upgradation from the cloud over the MQTT or and HTTP, IoT connected device. Drivers. The device have the drivers USB, CAN, serial port, Bluetooth, Wi-Fi drivers. Operating system, embedded Linux, kernel, Linux kernel, bootloader, U-boot. Hardware layer, the device have processor or microcontroller. So additionally, flash memory, CAN-FD interface, USB, serial port, Bluetooth, Wi-Fi interface. Based on this specification, we can discuss what security controls are required in each layer of the hardware. That aspect we can discuss here. Okay, embedded devices security controls. This is samples. Suppose if we take the communication data layer, so there firmware download provisions over the wireless as well as the wired. So security controls here recommended code signing for the firmware, software signing, digital signing for the firmware. So this is what we need to consider. Suppose if we are not implementing the security controls, signing or digital signature for the firmware tampering attacks, firmware injection attacks are the threats or vulnerabilities here. To mitigate that, we need to consider the security controls in the communication layer. Then the second controls, secure signing algorithms, hashing algorithms, keys, certificates, these configurations securely we need to configure both the device side as well as the IoT core side. Suppose if we miss these controls, it may give sensitive data leakage like exposing the keys, hashing algorithms, certificate details. So these type of vulnerabilities may expose here. Then the communication data, we have the HTTPS also. So strongly we need to encrypt using TLS certificate so that we can prevent data sniffing, MITM attacks on the HTTP communication. Okay, next layer is hardware interfaces. So first we can take the USB interface. There the device based authentication we can consider. Secure polling, when we connect the host devices over the USB, secure polling, device enumeration, drivers, USB drivers whitelist, blacklist and permissions. These security controls we need to consider so that it will help to prevent unauthorized device access. We can prevent using these controls. Then the serial port, drivers level, blacklist, whitelist. If required, login credentials for the serial port, console ideal session timeout. These aspect we can think so that it will useful to prevent unauthorized serial port access, unauthorized device access, unauthorized user access. So all this aspect we can prevent the security controls. Next one is CAN interface. There we can encrypt the communication CAN bus communication we can encrypt using CAN crypt some mechanisms, so that we can prevent sniffing, spoofing attack, injection attacks. Device based authentication. Now the latest scan stacks are providing device based authentication mechanisms to implement device to device or mission to mission communication, so that we can prevent unauthorized CAN bus access, bus off attacks, replay attacks. So multiple attacks we can prevent. Then the message, CAN data message permissions, read write permissions, we need to configure properly, so that unauthorized read write CAN messages, these type of issues we can prevent. Encrypt CAN DBC. So we need to encrypt the CAN DBC and we need to store on the device side, so that spoofing attack we can prevent. Okay, when we identify the Bluetooth related security controls, the device based authentication, secure pairing we need to consider, so that the unauthorized BLE connection access, these attacks or vulnerabilities we can prevent. Then Bluetooth data encryption also we need to consider. BLE data integrity or checksums we need to implement, and the secure version of Bluetooth stack we need to select. So these type of basic consideration we need to do when we identify the security controls for the Bluetooth stack. Okay, next one, Wi-Fi interface and Wi-Fi related data flow workflows. So here the secure version of the Wi-Fi stack, secure Wi-Fi algorithms, disable insecure version of the algorithms. So these aspects we need to consider when we gather the security controls for the embedded device. Okay, next we are coming to the embedded application layer. So in this sample device, we have three types of application level services. One is HTTPS web application, another one is MQTT, third one is SSH. So here the web application related authentication, user access control, session management, input validation, file upload, secure configuration, these aspects we need to consider, so that it will prevent to execute these type of attacks in the web application. Okay, embedded application for MQTT. Mostly the MQTT service we are connecting with the IoT core or IoT server with the cloud components, right? So that time the mission to mission TLS based certificate authentication, on top of that the MQTT application layer authentication, resource authorization, secure configurations. So these aspects we need to consider the security controls to prevent unauthorized access over the MQTT. Then SSH. Most of the Linux devices will support for SSH for debugging or management console management purpose, right? So the secure SSH authentication, configuration, user access controls, encryption algorithms, session timeouts. So these aspects we need to consider to prevent unauthorized access or data sniffing or data tampering attacks on the SSH communication. Next layer is driver, OS and kernel layer. So here OS level security like secure version of drivers, secure version of OS, secure version of kernel, these aspects we need to consider. On top of the OS, the network layer component, firewall, inbound outbound rules, TCP stack configuration, these aspects also we need to consider. Okay, then the bootloader, boot sequence, the secure boot we need to consider to prevent bootloader tampering or executing or booting the device with malicious bootloader. These attacks we can prevent. Secure U-boot configuration also we need to do to secure the bootloader configurations. Then the hardware layer, processor and other chipset, the trusted platform module, one-time programmable memory, read-write access, how we are configuring. So these aspects we need to consider. Flash data, how we are storing, whether we are encrypting, the read write permissions are set properly. This aspect we need to consider. Then secure version of Bluetooth chipset, secure version of Wi-Fi chipset are we using. These controls we need to do when we do the assessment on the hardware layer. This is the high level and sample security controls. When we identify the security controls for any embedded device in all the layers, we need to consider. Okay, for each architecture layer, practically how we need to create the security requirements, threat model, risk assessment, secure coding, penetration testing. These aspects I will give more details in the coming sessions. So with this presentation, I am ending this session. I will see you in next session. Bye.